let's continue. So we expect to see only changes at the cathode because they have used a wrong electrode here. Instead of using our common ones, we know, like carbon and maybe platinum, they have taken the graphite or platinum anode at the anode, and then they have put mercury at the cathode. Now, at the anode, we expect to see oxygen gas. That one is known now at this level, that hydroxide ions get the electrons to give us water and oxygen gas. When you try to balance, these are 2 hydrogens, oxygens are 2, this is 2 here, 4 of them. So here I put 4 and then 4 electrons. That is what we have. So at the anode, we expect to see oxygen gas. That one is known. Now, the problem is at the cathode. What do you expect to get from the cathode? Let's look at this. So let's start from here. Both chloride and hydroxyl ions migrate to the anode, but the hydroxyl ions being lower than chloride ions in the reactivity series, the hydroxyl ions are discharged by losing electrons in prevalence to the chloride ions. Therefore, bubbles of a colorless gas that lights a glowing splint is observed at the anode. Therefore, that's what is observed at the anode. When they ask you to write your observation at the anode, we expect to see, you tell them what you expect to see. Bubbles of a colorless gas that lights a glowing splint. That's what you expect to see. Then, and they ask for the equation. This is the equation you write there. Then at the cathode, both sodium and hydrogen ions migrate, move there. But in this case, we saw last time the other anode just dissolved in the solution. Now here, sodium ions are discharged despite the fact that hydrogen ions are lower than them in electrochemical series. So here in this particular case, now the reason as to why sodium is taken in preference to hydrogen, though it is lower than it in the electrochemical series, is that this is because the process requires less energy and sodium ions produced form an amalgam with mercury. So mercury cannot form an amalgam with hydrogen, no? It likes sodium. Since sodium is the most reactive, they form an amalgam. What is an amalgam? Who knows that word? Huh? Nobody knows.
Yes. Huh? Yes.
It attaches itself to the anode, and what you see is something that looks like this. What is this? This is something close to that. Huh? Have you seen what I'm sharing on the screen?
Yes.
That silver thing or mercury-like thing that looks like that, they always attach it to the teeth there. There are some people who have those teeth. You have ever seen one with that type of teeth?
Yeah.
Yeah, they have amalgamated them with the mercury, and when a person starts laughing, you only see those shiny things come. So that is what the sodium does with the mercury. They form that amalgam, yes.
Why is it attached on the teeth?
That is a design to them. Huh? But in most cases, maybe if you have cracks or whatever in the teeth, they can put it there. Otherwise, most people use them as just a source of maybe designing something. Musicians, they use it for design to look rare among the many. You get it?
Teacher,
Yes.
Yes.
when they put it on the teeth, does it have effects?
It may be in the long run, but if it doesn't, you will see what will happen. So instead of you having holes like these ones in the teeth, they put it there to cover that gap so that food particles don't go there and disturb you more. Okay?
Yeah.
So that is the meaning of the word amalgamation. So the sodium and the mercury form that amalgam. Check this one. This one here. So mercury always is like that. So when it sees sodium anywhere, they like getting stuck, or they stick to each other very fast than any other. So they throw away what? Hydrogen from the reaction, and they attract the sodium very fast. Is it clear?
Yes.
So that's what
Yes.
they form. So dental amalgamation of mercury is also there. They amalgamate your teeth with the mercury. They put it there for those who have failed to eat completely. Even there are those who put it in the tongue, by the way. Huh? So all those are part of that. So that is what you see this part of opening the mouth so that they put the mercury to fill those parts. Yeah.
Yellow.
So that is what happens there. So instead of allowing your teeth to decay in a bad way, they put that mercury there to fill. I don't know how that person feels. It is better to ask that person who has ever undergone that amalgamation. Okay? So the sodium amalgamates there, and what we see at the cathode is the sodium ions throw away the electron to become the sodium solid. So we expect to see an amalgamation between sodium and mercury. They form one element. Okay? So when that question comes, just tell them we expect to see sodium forming an amalgam and the hydrogen ions are left, though hydrogen is low in the reactivity series than sodium. Okay? So that is what we call the nature of the electrode for this time. When you get electrolysis of sodium chloride using a mercury cathode, and the anode is having this one. Now the other one was between the copper electrodes at both sides. So if you use copper cathode, actually if they change and they put now like this, the first one we did, and they say maybe electrolysis of copper 2 sulfate using, they change copper electrode, maybe copper cathode, and then platinum or carbon anode. What do you think is going to happen for this one? Because at the cathode, we expect to see copper ions and the hydrogen ions, and then anode, we expect to see sulfate ion and the hydroxide ions. What do you expect is going to happen in case they use copper cathode here? The cathode is copper, and then the anode is platinum. What do you think is going to happen? will this copper or will this anode or will this electrode disappear in solution?
Yes.
When they use copper cathode, and then the anode they use. Now mark this, that at the anode, this is what happened. The other at the anode, these things were not taken into solution, all of them. The reason is the electrode, that copper electrode, disappeared in solution. It went through the solution and disappeared. So the copper cathode was changed into ions and they all migrated to the cathode, leaving this electrode free. There was nothing here. Now, if you change this anode and put platinum, what do you think is going to happen?
It will dissolve.
The platinum will dissolve. It will go back to the other first state we looked at. That's the nature of the what? Unless they change and say we are going to use the copper, anode, and then the platinum cathode. Then this copper anode will change, will turn into solution to give us the other way around. But if the anode remains as platinum, still oxygen gas will be produced at the anode.
Teacher,
Yes.
why is it when you use copper and platinum, copper dissolves? But when you use copper and copper doesn't dissolve.
Copper and what?
Copper anode and copper cathode.
Look at this statement properly. Electrolysis of copper to sulfate using copper electrodes. Was there a platinum placed there? Both
No.
electrodes have copper and copper. You get it?
Yes.
Now, if they twist any, and maybe they, instead of the anode using copper, they put platinum, the thing goes back to normal, just like this one here. Do you see this? What did they use? Electrolysis of copper to sulfate using copper cathode and platinum or graphite anode. Do you see what happened here? Have you seen that?
Yes.
So this is what happens.
Teacher.
Yes.
If the anode as the cathode, the anode will dissolve.
That's not the case. It is a case if they use copper sulfate solution using copper electrodes. You get it?
Yes, teacher.
But if they use copper to sulfate solution and they use carbon or platinum electrodes, the normal reactions will happen using the first word. But if they twist them, okay, actually, if they use copper cathode and then platinum anode, then the solution will also remain the same. But if they use only copper anode, copper cathode, then you will know what will happen. That one of them will dissolve in the solution, isn't it?
Yes, teacher.
So I want you to get this book and you read, you get this part. You read that part that requires you to determine the nature of the position, actually the three factors, preferential selective discharge of ions. You look at what they say, that the position of the metal in the electrochemical series, and you also look at the electrodes they used. Now, like this one, electrolysis of the sulfuric acid, they use platinum or carbon electrodes. This is the normal state. You are supposed to use platinum or carbon electrodes. But the moment you twist, now like this one, example 2, dilute sodium hydroxide using carbon electrodes, that is another way. That one is okay. Now here also, you are looking at this electrolysis of copper to sulfate solution using copper cathode and the platinum or whatever anode. Then I want also to look at a state where they say we are going to use platinum cathode and then copper anode. You get it?
Yes.
Yes, teacher.
So that is the state I want to look at. Now, this one will bring us to this argument here down of B, which is the nature of the electrodes to be used. When you talk about the nature of the electrodes, it is these rods we are talking about, not the solution again, the electrodes being used. Now you are electrolyzing copper to sulfate, but you are using 2 electrodes of copper at the anode and the cathode at the same time. So at the anode, we have copper. At the cathode, we also have copper. So what will happen is, at the cathode, instead of taking the hydrogen and the sulfate, they won't be discharged. Actually, this anode will dissolve in the solution and it goes and packs itself here. Is that clear? Yes? So that is what we have there. Now, even this one of sodium chloride using a mercury, when you see mercury cathode and the graphite anode, at the anode, we expect to see normal reactions. At the cathode, that's where we expect to see changes, because this is mercury and sodium, they have that attraction, they make amalgams very fast, so they throw away who is that one? So that's what they do there. Now if you look at the next example, actually those are the 2 examples we have there. And okay, we still have some minutes there. So where are the questions? We first put those things right before we jump anywhere. Do you have any questions?
Teacher,
Yes.
there's something that has been confusing me. What determines the dissolving of the anode or cathode?
The dissolving of the anode and the cathode.
Yes.
When you use the electrodes, you get it? Electrodes. Now, when you want to know that electrodes, the common electrodes used are platinum and carbon electrodes, isn't it? Yes?
Yes.
Yes.
Now, instead of using these electrodes in solutions like this is when they say graphite is part of carbon, isn't it?
Yes.
These are the electrodes. Instead of using carbon or platinum here, and then instead of using carbon or platinum, you decide to twist your electrodes by say, let me use, I want copper to sulfate solution, but I want to electrolyze this, but I'm using the same electrodes of copper electrodes. Meaning you are going to remove this and this. Now, when you use these copper electrodes here in the solution like this is copper, this is a copper electrode. Now, this one, if this is the anode, this is the cathode. Remember, the anode will attract negative ions. Then the cathode will attract positive ions. Now, instead of these, the electrodes are the same. Instead of this copper anode attracting the negative ions, it will refuse all of them and decide to dissolve in solution there and goes back and attaches itself to this here. Nature of the electrode has given us that answer. Now, also, if you look at sodium chloride, dilute. Instead of giving us positive results, now they have used which electrode did they use? Mercury, and then carbon or graphite. Now, instead of the mercury taking sodium and hydrogen ions, instead of taking hydrogen ions, it has decided to take sodium because they make an amalgam very fast. So this formation of this amalgam requires less energy to produce it. Therefore, it will take the sodium ions very fast and leaves the hydrogen there. But at this electrode here, this is the cathode, this is the anode. At the anode, no more reaction will occur. If it is a chloride and hydroxide, we expect to see oxygen gas produced. But if this is a mercury cathode, it will attract positive ions. When positive ions go there, they will throw away hydrogen, though it is lower in electrochemical series, because formation of an amalgam of sodium and mercury takes little energy. They will form the amalgam very fast and leave the hydrogen there wandering in solution. Also here at copper, the same thing happens. Instead of this attracting the negative ions, since the process requires less energy for this electrode to disappear in solution, it will leave all the others and self disappears in solution and goes and attaches self to the cathode. Okay?
Yes.
So
Teacher,
look at, yes.
if one of the anodes, one of the electrodes dissolves or forms an amalgam, that means there is no conduction of electricity.
They will conduct. That's why those electrons are moving from one place to another. You get it? Yes? Yeah, it will conduct electricity, even if it forms an amalgam. This is a solution. It has two ions, hydrogen and sodium. So if one of them has attached itself to the electrode, the other one will continue passing the what? The electrons.
Teacher, you mean only mercury gets attracted to only sodium? How about other elements?
That is, they require high energy. So anything that requires much energy, you need also to increase on the conditions here. But if it is this normal electrolysis, it is only sodium that requires less energy to form the what? The amalgam. As long as you have put sodium chloride in anything that has sodium in solution, okay, with mercury, they will always grab sodium very fast and they form an amalgam.
Teacher, now if they put a substance, like they put it with a hydrogen, and that element is above hydrogen in the reactivity series, and apart from sodium, so you're going to take hydrogen that is going to be deposited there.
They have chosen only these two because they are the rare ones they normally meet there. But if the rest is there, then the other part A, that is the position of the element in the reactivity series takes over. Is that clear? It is only these particular two that give us headache always. But if the others are there in the solution, apart from this, then the thing goes to its normal reaction. Okay?
Yes.
We are left with one to finish these troubles here. That is concentration, the concentration of the electrolyte. We are also going to look at that. And if these two are giving you at the time, then concentration is also there. Maybe concentration will be easier. Questions? Shelly?
Yes, teacher.
There is no question. Cynthia has decided to take off from this lesson here. She doesn't attend. Now, if there is no question, then let's finalize this by looking at this concentration. Let me choose Maya. Maya.
Yes, I can hear you.
Very good. This is concentration up to where this full stop is. You can read for us.
Increase in concentration of ions tends to promote its chance of being discharged. For example, if concentrated hydrochloric acid is used.
Okay. Now, they are saying that increase in the concentration of the ion tends to promote its chance of being discharged. Not following the other first one, the first one told us that the position of the element in the reactivity series gives something a chance of being taken up by the electrode. Now here, if something is in a much concentration, it has higher chances of being discharged at the electrode. An example is concentrated hydrochloric acid. If you use concentrated hydrochloric acid, this is what happens. Electrolysis of concentrated sulfuric acid. This is conc hydrochloric acid. Now, if the acid is conc, we look at what is there. Concentrated, it doesn't mean that it has no element of water. Still, it has water in it, isn't it?
Yes.
Yes.
So here we shall have HCl aqueous. Then we shall have hydrogen ions and the chloride ions. Plus, also we have water. We have hydrogen ions plus hydroxide ions. Now, since this substance is concentrated, this is what we see at the anode. We expect to see, since this one is positive, it attracts negative ions. We expect to see chloride ions and then hydroxide ions. And then at the cathode, we expect to see hydrogen and hydrogen. They are the same ions. Now, at the cathode, we are safe. We expect to see hydrogen gas, isn't it?
Yes.
What about the anode? What do you expect to see at the anode? Preferential discharge tells us that hydroxide ions will be taken up more than this. Now, this one is based on the concentration. We are dealing with the concentrated sulfuric acid. At the anode, do you expect to see this? Both chloride and hydroxyl ions migrate to the anode, but hydroxyl ions, despite them being lower than chloride ions in the electrochemical series, are not discharged. Instead, the chloride ions are discharged because they are present in a much higher concentration. So concentration affects the nature of discharge. If they say, give us or describe the electrolysis of concentrated sulfuric acid, you should know what they mean by concentrated. If something is concentrated, then the one that is much higher in the electrochemical series will be preferred more than this, because this one is less. The electrode cannot take up this. No, it will take up what is present. So at the anode, we expect to see a chloride losing electrons to become chlorine gas. So if you try to balance, these are these two, since they are two, they can't attract one electron. They also attract 2 electrons. So expect to see chlorine gas, a green gas at the anode, and then also at the cathode, we expect to see hydrogen gaining the electron to give us hydrogen gas, hydrogen ion, gaining the electron, losing the electron to give us hydrogen gas. So when you try to balance, this is 2 and then 2. So at the cathode, we expect to see hydrogen gas. At the anode, we expect to see a chloride gas. Okay.
Yes.
Now, if we are saying electrolysis, now here you look at the electrodes being used, using graphite what? Electrodes. Have you seen what they are using in concentration? Yes?
Yes.
Secondly, even here,
Teacher.
in this one, yes.
On the question that we just did about the concentrated hydrochloric acid. So you think like those elements which are higher have a higher concentration than those ones below. Like chloride has a higher concentration than hydroxide.
No, we are dealing with concentrated sulfuric acid. You get it? Hydrochloric acid, I mean. Concentrated hydrochloric acid. So this one, hydrogen ions here will be much. Even here, chloride ions will be what? Much. Though at the anode, a chloride and hydroxide ions will all migrate at the anode. Now, it is that electrode called anode to decide which one is it taking. It can't take hydroxyl ions because in the reactivity series we saw, hydroxyl ions are down, then chloride ions are up. In selective discharge, it would have taken hydroxyl ions. But because these ones are low in concentration, they can't take this. They take the chloride what? Ions. Now here we have hydrogen and hydrogen. It is the same thing. We expect to see hydrogen gas. So if this was another thing here, maybe sodium, you would see hydrogen being taken because it is in much concentration in relation to the one below. Is that clear?
Yes.
Okay, if that is clear, somebody give me what are the end products in electrolysis of concentrated sodium chloride. Sodium chloride using graphite electrodes. Graphite electrodes. You see, in most electrolysis, they use graphite. Now, if you twist the electrode, you are going back to the other whatever, to the other nature of the electrode, and to give you the answer. So let's base on concentration to determine the concentration of sodium chloride. What's going to be formed at the anode and the cathode? Let's do it in a few minutes. I want to see the answers. So these are the type of numbers that always come in paper 2 chemistry. If you fail to understand anything, you jump, and yet they are the easy numbers to write. No much writing equations as long as you how to derive the ionic ones, you start the journey. Time is going. What do you find at the anode? What do you find at the anode?
Chloride.
Chloride, yes. Cathode?
Sodium.
Hydrogen.
Find chlorine gas at the anode. Chlorine gas at the anode. And then cathode?
Sodium.
All right.
Yes.
Sodium.
Cathode we find sodium.
Sodium.
We expect to see sodium ions
Yes.
at that. Okay. So now let's reason it out properly. That's what we have, isn't it?
Yes, teacher.
At the cathode, there is a difference here. Both sodium and hydrogen ions migrate to the cathode. Hydrogen being lower than it in electrochemical series are discharged in preference to sodium ions. Therefore, bubbles of a colorless gas that turns lime water milky or burns with a pop sound is produced at the cathode. Is that correct?
No.
So what is your argument now? That a person has learned what? Give me I want people to argue. What is not there? The teacher has the answer. What is the answer?